Hello friends, in the last video I have explained about the liquefaction phenomena which is responsible for many failures during earthquake. So how to find out at a particular site the liquefaction potential? So that's very important. So determination of liquefaction potential of a site is now mandatory in India. So before construction, when you go to a site, you need to find out whether this ground will liquefy when the earthquake is going to strike. So during the earthquake, this particular site, before construction takes place, you must find out the liquefaction potential. And the various field tests that you can do it are known to you. Either you can perform a standard penetration test and find out the N value, the number of blows required for 30 centimeter of penetration at the site. So in the field, you can find it out, or you can go for cone penetration test, CPT, and you can find out the cone tip resistance and the slip friction, or you can also perform the shear wave velocity test. So these are the tests, and IS 1893 part 1 2016, they have come out with a simplified approach which is based on Seed and Idris technique, his research paper. So today we would like to highlight the Codal provision for determination of liquefaction potential of a site. So we will be dealing with IS 1893 based on IS 2016, and it talks about the simplified procedure for evaluation of liquefaction potential. Potential of a site. So this is very important, and we'll see that based on SPT, number of blows, how will you find out the liquefaction potential of a site? So as given in this code, the first step is to perform SPT, find out the field N values and correct it for overburden. And therefore, for a site, for the given site, what you will have to do is to perform standard penetration test and find out and record, not find out, and record the SPT blow count, capital N. Also, you should find out the percentage fines present in the granular soil mass and its unit weight. So first thing is we have to go to the site and perform SPT and find out the number of blows required for 30 centimeter of penetration. That is called blow count. So record the SPT blow count and find out the percentage of fines and also the unit weight. Also, groundwater table is very, very important. So what is the groundwater table? Also, record the ground water table position. First thing, going to the site where the construction is to take place, we should do this much. Then having done this, now you should find out the effective overburden pressure at different depths. So find out or calculate the total and effective overburden pressure, vertical, at different depth, at various depths. Z. So you can find out, that is, you will have to calculate sigma V naught, that is the total vertical overburden pressure, and sigma V naught prime, that is effective vertical overburden pressure. So these two things you should find it out. Then you can apply correction to N value, or if you calculate this. Also, you should calculate the stress reduction factor. Calculate the stress reduction factor, RD. This stress reduction factor, RD, depends upon the depth. So it is given as 1 minus 0.00765 Z, where Z is the depth. For 0 less than Z less than equal to 9.15 meter. So up to 9.15 meter from the ground level or from the ground surface, the stress reduction factor RD you can calculate by using this expression. So this is the expression that you can use it, or this is equal to 1.174 minus 0.0267 Z for Z less than 9.15 or 9.15 meter less than Z less than equal to 23 meter. This is how you can calculate the stress reduction factor. Having got this, next you can calculate the cyclic stress ratio. So calculate cyclic stress ratio, CSR. In my last video, I have given you a complete idea about the cyclic stress ratio due to earthquake, how the cyclic stress ratio is going to develop due to the shear force or shear stresses. So here the value of CSR you can calculate it, and that is given as 0.65 into maximum acceleration or peak ground acceleration divided by G into vertical overburden pressure upon effective vertical overburden pressure into a reduction factor. So this is very important. Calculate CSR, and very simple. It is the 0.65 into A max upon G into sigma V naught divided by sigma V naught prime into stress reduction factor, where A max is peak ground acceleration. So where A max is peak ground acceleration. This peak ground acceleration equal to seismic zone factor, capital Z. So for every area you have a zone factor. In different zones you have got different zone factors, and if the A max by G is not given to you, G is the acceleration due to gravity. G is the acceleration due to gravity. If it is not given, then you can find out the zone factor. Say in zone 4, the zone factor is given to you, 0.24. In zone 3, it is 0.16. So you can find out A max upon G, and A max is called the peak ground acceleration. And this is equal to the seismic zone factor. So very easily you can find out all those things. Having found out this, the next step you should go for calculation of CRR, that is cyclic resistance ratio. In my next video, I have already defined what is cyclic resistance ratio. The ground is going to offer the resistance against cyclic stress ratio, which is developed due to the earthquake. So this cyclic resistance ratio is to be calculated, and in the IS code, you will be finding out CRR for the magnitude of earthquake equal to 7.5. So it is very simple. CRR for any magnitude can be found out equal to CRR for 7.5, which you can always find out from the chart, which is a function of the ground resistance, and in SPT it is the function of the corrected N value for overburden correction, multiplied by the magnitude scaling factor multiplied by K sigma into K alpha. These are the factors. So MSF is called magnitude scaling factor, and this is equal to, in the code it is given 10 raised to 2.24 divided by the magnitude of the earthquake, MW raised to power 2.56. So the magnitude scaling factor can be calculated. K sigma is due to the overburden, and this is the correction for high overburden. Correction for high overburden pressure, and this is for the depth greater than 15 meter. When the depth exceeds, then K sigma, you can calculate it if the depth exceeds 15 meter, and this is equal to sigma V naught prime, that is the effective overburden pressure, divided by atmospheric pressure raised to power F minus 1, where this atmospheric pressure is called the atmospheric pressure, which is equal to 101.325 kilopascal. And the value of F depends upon the relative density of the ground. So this F is a function of relative density of the ground. So what is the relative density? So for relative density, if it is between 40 to 60%, 60%, then this value of f is going to be in this range, 0.8 to 0.7. But if it is 60 to 80%, if dr equal to 60 to 80%, then the value of f is going to be 0.7 to 0.6 in this range. So you can find out this. You can find out this. This you can get it from the chart given in the IS code. And this K alpha, this one equal to 1 for level ground. So if the ground is level, then the value of this K alpha equal to 1. If it is sloping ground, then the shear force comes into picture. The ground is sloping in nature. If it is sloping ground, then if you take any element, then you are also going to have a shear over here. So the soil element will be subjected to shear in addition to the overburden pressure. So then K alpha is for sloping ground. Otherwise, it is to be taken as 1. Now, you will have to normalize the value because you have performed SPT test and recorded the number of blows. So the next step will be to normalize So our next step will be to normalize the SPT blow count, that is N's number of blows, N60 it is called. So normalize this to effective overburden pressure using correction factor. Using correction factor Cn. That means the corrected value N1 will be the correction factor N1, which is a function of this, and into the number of blows from SPT at this site. So what is the number of blows? N multiplied by the correction factor Cn. Now, how to find out this correction factor? It's a simple expression that's given in the code, that Cn equal to, the simplest expression is under root Pa divided by sigma V naught prime. So it's a function of this, and Pa is the atmospheric pressure. So Cn can be found out, should be less than equal to 1.7. That's the limiting value of Cn. And once you get this corrected N1 value, find CRR for magnitude of earthquake of 7.5 from the figure given in IS 1893 part 1 for corrected or normalized N1. So you have calculated N1 and therefore you can find out the value of CRR 7.5. So you can obtain very easily from the figure, and then if you substitute it in the expression for CRR equal to CRR 7.5 into MSF into K sigma into K alpha, you can get the value of CRR. So having got the value of CRR and CRR value, you can next go for calculate the factor of safety F against liquefaction. Therefore, F equal to the factor of safety equal to CRR, the cyclic resistance ratio, upon CSR. And if you find that it is greater than 1.2, no liquefaction. Otherwise, your site is going to liquefy it. So, determination of the factor of safety against liquefaction is the determination of liquefaction potential of a site. So, for any site engineer or any civil engineer, a structural engineer, whenever you are going to construct a structure, it is mandatory in India and across the world now to find out the liquefaction potential of a particular site. Now you can also find out the liquefaction potential of a site based on cone penetration test. That is also a field test. So in my next video, I will let you know using cone penetration test how to find out the liquefaction potential of a site. So friends, today we are going to cover only this much. So thank you very much. I hope you have understood it. In the next video, I will solve a problem based on these steps so that things become crystal clear to all of you. Thank you.